Good evening, everyone. My name is Nick, and I'd like to welcome you back to another Tech Talk in our series sponsored by Pressable. Tonight, we have the pleasure of welcoming Micah for his talk on integration testing. So without further ado, I'd like to pass it over to you, Micah.
Thanks, Nick. Good evening, everyone. Thank you all for attending tonight's event. Before we get started, I want to thank Pressable for sponsoring this Tech Talk. My name is Micah Ziegler. I'm a software engineer, and some of you may remember me from my first Tech Talk earlier this year. If you were unable to attend that event, I discussed best practices when it comes to software testing and did a brief comparison between Jest and V-Test for unit testing. You can find that recording on YouTube or my LinkedIn if you want to check it out. I also mentioned how integration testing would take up a whole other Tech Talk, and that's why I'm back tonight. Welcome to Testing 201, Integration. Let's get into it. The best answer to the question, what is integration testing, also answers the question, well, if I have unit tested everything, why do I need integration tests? Well, just because code A works and code B works doesn't mean that they work together. And you don't want to rely on unit tests only to find that when you test your production build just before deployment, there are errors somewhere in the complexity of your numerous modules that have somehow been pieced together incorrectly. And now you have to traverse through all of those connections to find the bent needle in a haystack. You might have had the image of a jigsaw puzzle pop into your head, and that's a great representation of why you need integration tests. Each function is like a single puzzle piece, and each module is a collection of some of those pieces put together successfully to form a part of the picture. Sidebar, if you don't tackle jigsaw puzzles by building distinct parts of the picture first, like individual hot air balloons or specific rooftops, then I highly recommend seeing a clinical psychologist because something is wrong. There is only one correct way to build a jigsaw puzzle. End sidebar. Once you have those clumps of the puzzle built out, the specific pieces that connect those clumps together are often the hardest to find and easily mistaken for each other because they're serving as the bridge between two images, which can be a little more muddy. But you still have to make sure that you're using the correct pieces in order to get a complete puzzle at the end. So here are some examples of what might cause integrated code to fail. These are those pieces that look like they should fit, but they're just not quite right. Inconsistent code logic. On any project with more than one developer, there's going to be code from dev A that's connected to code from dev B, and their coding backgrounds and approaches to the problem will be different. So their code is probably going to look different. And you have to make sure that those differences are still compatible. With bad data, data is often passed between developed modules, and you'll probably unit test the module that generates or acquires the data to ensure that it works, and you'll probably unit test the module that uses that data functionally with mocks or dummy data and prove that it works. But if you're not correctly bridging those two modules, the functional module may never receive any data, or worse, it may receive the wrong kind of data because it's not accessing it correctly. Integration tests will help you catch and locate those errors immediately, expediting the debugging process instead of discovering the issue later and having to try and figure out the source of that problem. Now, the risk of bad data is also true and even more important when you're working with imported external modules and APIs because you only have control over one side of that interaction. So again, having those issues flagged early in the process will help expedite that debugging. When it comes to edge cases, good code and good tests will take edge cases into account. However, sometimes you can't see all of those edge cases until you start putting the pieces of your code together. Building integration tests will help you think of those possible scenarios in advance so you can stabilize your code before you merge it with the rest of your project. So how should you build integration tests? Well, there are two common approaches. First, the Big Bang approach is when you take the entire code base as a single entity after everything has been integrated. Now, this is really only a viable approach with small systems or proof of concept projects when integration tests on a smaller scale might just interrupt your team's workflow more than is necessary. Or if you are working with a large, complex, pre-existing code base where it makes more sense to test what's already working rather than trying to dig through the pieces to find the connections that you need to test. But overall, this isn't a great approach as a testing methodology when you're building, because you can't really start working on the integration test suite until the whole system is built out, which means debugging is delayed until late in the process. And as I mentioned before, Now you have to work through the entire structure instead of knowing exactly where you want to build. For a more common day-to-day integration test, I suggest going with the incremental approach, where if modules interact directly, you test only those specific modules together. This approach means that testing is an integrated part of your development process, which leads to more stable code. The only downside is the feeling that there are pauses in development, especially when you don't have a dedicated testing team for your project. However, you should, and hopefully your client does as well, value quality over quantity every time. Now, there are two subcategories to the incremental approach. First, there's top-down, and you can think of that like a component tree. You start at the parent module and test the connections to its children, and then the connections between those children and their children, and so on. But sometimes a lower level module may not be fully developed. So you can't use a function within that module in order to test the connection to adjacent or parent modules. However, if you know what that function will eventually do, you can use stubs in the meantime. Stubs take the place of undeveloped functionality in lower modules when testing the bridge between modules. They behave like mocks in that they serve predefined responses so that other dependent functionality can be tested. The reason we don't use mocks specifically in integration tests is because they take more work to accomplish the same goals as stubs. Mocks can track stats like how often they're called and the data that goes in and out of them, which is great for unit tests when you're verifying functionality. But at the integration test stage, that's unnecessary and inefficient. You're already going to test the function itself in the unit suite. So here, we're going to assume that the function will work, and we're going to use a stub so we can focus on the connections between modules and functions. An important note at this point is that if you have to use stubs or drivers, which we'll get to in a moment, you can't forget about them. You still haven't fully tested the actual connection between modules, just what module B or E or F should do, assuming it gets the proper data from module D. Once that lower level module is fully developed, you have to go back and make sure that connection itself is operating and tested correctly by replacing the stub with the actual function. Dot your I's, cross your T's. Another note on that, if you're testing connections to an API or in an other external dependency, especially one you have to pay for, after you've tested and verified the connections between those two modules and you're pretty sure developers aren't actively modifying those modules unless some change in scope occurs, you can mute out those real world calls and unmute the stub test you've written so you can avoid those unnecessary costs, throttling, rate limits, those sort of things. All that to say, if you have to write a stub for undeveloped code anyway, don't just get rid of it when the actual code is finished because it's easy enough to hop back and forth. You just have to make sure you're keeping track. So that's the top-down approach to incremental integration tests. Now let's talk about bottom-up. The problem with the bottom-up approach is that the lowest level modules might be affected by every layer of modules above it. Module D is influenced by module B, which is influenced by module A. That means I can't fully test the actual connections and integrations for module D until all of its connected modules are developed. Whereas with top-down, I only need two modules to be fully developed to completely test that integration. I can fully test A to B, and I can fully test A to C, even if none of those lower modules are fully developed. The other problem is that you have to use drivers instead of stubs, and drivers are just a little more complicated. Remember that stubs take the place of undeveloped functionality in lower modules when testing the bridge between modules. Drivers, on the other hand, take the place of undeveloped upper modules that serve as that bridge when you're testing coupled functionality. Another way to think of it, stubs replace dependencies, drivers replace orchestration. So instead of a stub imitating the returned result of missing functionality, a driver is a function that calls multiple functionalities across different modules. Let's take a look at actual examples of a driver and a stub next to each other. So just because I know it can be a little confusing. Here's a driver. The goal is to make sure that two functions that are connected but located in different modules can work together. The upper module that will orchestrate the connection isn't ready yet, but for this test, we are assuming that it will work when it's ready. So we're going to import the functions we're testing into our test file, here fetch data and process data. These wouldn't be hard-coded into the test file in real life. That's just so you all can see the functionality that they should be doing. So the functions are imported, and our driver starts on line 21 and mimics the code that will eventually reside in that upper module. There's a defined API, and the function process data will be invoked on the evaluated result of invoking fetch data on that API. Okay, so the driver is acting like that upper module where these separate functions are going to be called to work together. Now, here's a stub. The goal here is to make sure that the connection between two functions in separate modules works. One of the functions isn't ready yet, but for this test, we are assuming that it will work when it is ready. So just like the driver, we import the developed lower function and the developed orchestrator function, and we have a stub taking the place of that second lower function on line 60. And all the stub function is doing is returning dummy data, because again, we're not testing that specific functionality. We just need data to feed into the orchestrator that we're testing on line 70. Okay, so there's the difference between stubs and drivers. You can see that stubs are a lot more straightforward because they're just spitting out set data. So why would I use a bottom-up approach that needs drivers? Well, partially the decision is driven by what's available to test and what's most important to test. Most of the time, developers are building the core functionality first, and that core functionality is sitting in those lower level modules. So you may have to work from the bottom up simply because that's what's available. It's also the foundation of the code base, and the higher you go in a module hierarchy, the less significant those modules themselves are. Think of like the app component for a React project. Sometimes all that module is doing, or that component, is serving the root component and defining the routing structure, and that's it. There's not really weighty functionality happening there, so it's not as important to test, and it will be a lot simpler to test when the time comes. So my advice is to use the top-down approach when you're put in charge of writing integration tests for an already mostly developed code base. Maybe you're iterating on a project, or you're brought into a team specifically to be their QA dev, because the top-down approach is going to use stubs more than drivers, and because by starting at the top where the tests are going to be simpler, you can be a snowball where you're starting off simple and fast, and you only get into bigger, more complex tests after you've built up momentum. You also may have a better understanding of the bigger picture of the code base and those connections you're testing, because you're moving from beginning of the flow of code to the end. But more likely, you're going to take a bottom-up approach, because if a project is still very much in development, those are the modules that will be available to you to test, and those are the modules that are going to be highest priority when it comes to stability and security, because that's where the core functionality lies. So who should be in charge of those tests? Well, depending on how your team is set up, and if you're trying to follow TDD methodology, it's likely that each dev is writing their own unit tests for the features they are building before or as they're building them. But what about integration tests? The integration test suite is not going to be run nearly as often as the unit tests, but it does require a greater understanding of the project as a whole and how all the modules fit together. So I do recommend having one person at least lead the development of your integration test suite. Even if you don't have an employed QA developer, assign that responsibility to one of your devs so they can focus on that big picture and those connections. Now, I'm going to call that person the QAD from now on, because I like saying that more than test dev or testing developer. So for the QAD, I would start writing the integration suite at the very beginning of the project, and make sure to set up automated testing with CI/CD tools like GitHub Actions, GitLab, or Travis CI, just to name a few. These will allow you to run your test suite on specified triggers. For instance, you can run them on all pull requests, because no matter how big or small a PR is, you want to make sure that function or that module is working within the shared framework of your dev branch. So at the beginning of development, write basic tests to get started, just to cover your bases. Make sure no one pushes that big red button and blows up your application. From there, continue to add and adapt your test suite as the project grows. Remember that automating your tests is not about being able to write a test and never see it again. As the QAD, you should check on your test suite during every pull request and code review, and update it with new and modified tests based on the project needs. The automation process is for the core developers, so they don't have to worry about manually running tests whenever they want to merge code, but those tests are guaranteed to run before that merge happens. As for those devs that are not working on the integration testing, If you ever hit a bug, especially if it deals with other modules, tell your QAD about it so they can add that scenario to their suite if necessary. No bug is too small, and communicating those errors will help you understand the problem and possible solution better, and it will help build a more robust test suite, which is better for your project as a whole. And finally, when you want that signed off, fully developed stamp of approval on a module, this is done, we're not coming back to it unless the scope changes stamp. That's when the QAD should go over that module and the associated tests with a fine-tooth comb to make sure every connection is being tested under all the different scenarios. For most of the project, a QAD will probably hop between modules as they become available. But whenever a module is ready for that major PR, the QAD should hone in on that module and focus on finishing its integration suite. Now, to wrap up this evening, let's talk through a simple workflow config for GitHub Actions so you can all see just how simple it is to get this started on your project. So first, add a GitHub Workflows directory to the root of your repository and create a YAML file in that workflow folder where you'll define the workflow configuration, which you can see here. First, you're just going to name your test and define your trigger. That's what's happening on lines 3 through 6. We want the job below to run on pull requests to the dev branch. Now just define the job. We call it test and assert that we want it to run on Ubuntu in this case with a Node.js container. Defining that container is going to automatically install Node.js at the specified version, and we're going to automate the install of any dependencies you've brought into the project with line 17. This all just saves time and ensures that the context and environment surrounding these tests are the same for everyone submitting a pull request. Line 14 is just telling GitHub to check out the branch that is being merged into dev, so it's testing the correct code. Then you call the same test command you've defined in your package.json, and finally, you call your build command, which only runs if the tests have gone through successfully. After this workflow, your code is tested and ready to merge into your main code base. And that's it. That's all you need to implement automated testing for your project. Here's my works cited. Thank you all so much for coming out tonight. I hope you can walk away from this talk with a better understanding of integration testing and how you can build it into your project and ultimately produce higher quality, more secure code for your clients and your users. If you have any questions, feel free to connect with me on LinkedIn and respond in the comments. I'd love to talk more. Thanks again to Pressable for sponsoring this Tech Talk. Good night.
Thank you very much, Micah, for that talk on integration testing. That was a very comprehensive overview. Unfortunately, we don't have time for questions tonight. I'd like to thank everyone for coming out, and we'll see you at the next one.